Yeah, I think it's recording. Okay. All right, yo. I'm gonna share my screen and we'll get started. Okay. Zoom people, can you hear me?
Yes.
Nice. Thanks, bro. Okay, so this workshop, hopefully we take like 30 minutes tops. We're gonna try and get through it. This is about Rust and writing a command line application. So what is Rust? It's a language that has been around for maybe 10 years or so. It was developed by Mozilla, same people who made Firefox. It's used a lot in systems programming. So for example, if you're writing an operating system, if you're doing something low level, you might use Rust. It's used a lot at companies like Meta, Amazon, Discord, Google, Dropbox. So it's kind of still in the early phases, it's catching on. We'll see where it goes, but a lot of people have very high expectations, good expectations about Rust. Why you should use it, it's designed for performance, reliability, safety. It's good for large distributed systems. So if you have software that exists across many servers or many computers, it would be a good fit. And a lot of its tools are very well respected and they're like super easy to use. For example, in Rust, when you run into an error, your compiler will give you a message that's usually very clear. It's like much more easy to understand than C++, in my opinion. And learning Rust will also teach you a lot of things that you can apply to other languages like operating systems or learning about memory. You also learn a lot just by learning Rust. Here's kind of like an example screenshot. Right now, this engineering director of Facebook says they're hiring people who are using Rust. We're looking for Rust users to make it a first, to use it at Meta. And he even talks about some of the tools like the IDE and the debugger. And there's even remote work. And then there's a link here about how Discord is also trying to switch some things to Rust. I actually think the feature they talk about in this blog is when you log into your Discord server, it tells you which channels you have read and which channels you have not read. So they were using another language, they were using Go, but it was having a lot of like slowdown issues. So let's go through the basics real quick. To declare variables, it's kind of similar to JavaScript. If you've seen it, you use the let keyword. You should also be specifying the variable type. That's like what you're supposed to do. So if you want to declare an integer, you just use this annotation over here, x I32, which means it's a 32-bit integer. If you want to declare a mutable variable, this is a variable that you can change or reassign, and you have to use this keyword, mut. If you leave it out, then the variable's like a constant. You can't really mess with it. If you want to use characters and strings, it's also pretty straightforward. But if you want to create a string that you can actually change and like remove and append to, you need to use the mut keyword again, and you need to build it a little differently. The syntax is a little different. Tuples and arrays also exist. If you've worked with Python, you know what tuples are. They're just arrays that contain different data types. And you can also annotate, you can also indicate the types of the items. Here's an example of an error message with Rust on the bottom. If you were to go out of bounds, the actual error message will say out of bounds, and it'll even tell you the length you're working with is 5, but you picked an index that's too large. So C++, I think, won't tell you that much. If you want to use vectors, you can also do it. Like these are just arrays that can grow and shrink. Functions are pretty easy as well. You just have to annotate your types. Here's what a print looks like, print line. And if you notice on this code in the bottom, y plus z is what gets returned. And that's another interesting thing about Rust. You don't need the return word. You can just do y plus z and like it'll return y plus z. If statements, those are pretty straightforward also. Loops, you can loop through, you can cause an infinite loop. You can use while loops. You can also iterate kind of over each item in the array. You do 4 item or 4 element in the array. Here's a struct. These are really common in Rust. You should probably know how these work. And if you've taken C++ classes, you know how they work already. Compiling and running. So this is like the bare minimum to build a Rust program to make it work. You want to create a file, hello. You want to create a file, and then in this one, it's hello.rs. It's just a hello world. And to compile, it's Rust C. And to run it, it's very similar to running an executable on C++. / Rust has crates and modules. So if you're familiar with things like namespaces and libraries, this is what Rust calls them. It calls them crates. So in this middle code, there's a function that takes in 2 numbers and it gives you the minimum. But for you to actually use that function, you need to import the right libraries. You need to use the right crates. Some advanced features of Rust. So this is more like what makes Rust different. And there's a lot to cover, but I'm basically just going to talk a little bit about this right here, which is understanding ownership. So ownership is like how Rust handles its memory. If you worked with C++, you know that you can get these errors called segmentation fault. It means you allocate memory, so you create like a pointer and it points to some location in memory. But for whatever reason, like when it's time to free the memory, the program doesn't know this and it tries to access this location in memory that's no longer valid. And here's where it gets interesting. Like, why is that important? If you notice here, Rust uses an approach where memory is managed through a set of rules. It's called ownership. If any of the rules are violated, the program won't compile. So in C++ or C, a lot of issues related to memory or segmentation faults, things like that, they won't come up until you actually run the code. So that's like the reason Rust was made with a certain principle in mind, that you should catch these issues before you run the code. So in Rust, everything is built around that. You're supposed to try and catch these errors when it compiles. And then the compiler is going to tell you, hey, something's going to go wrong. You're like using memory that's not valid, that it's going to be free or something like that. I also suggest that you look up this particular documentation we're on. If you're looking at this recording or you're on here and you want to learn Rust on your own, you just Google the Rust book. And this is basically the official place to start right here. And then you can read more about this subject. So right here, this is kind of like good reading for anybody who's learning C++ and wants to know what the stack and the heap are. This definitely applies to Rust. You need to know how this works. So for example, data with an unknown size at compile time must be stored on the heap. So this is what we mean when we say allocating memory. So I'll give you an example of what all this means, like an actual example. In Rust, there are these ownership rules, and there's basically 3. Each value in Rust has a variable that's called its owner. There can only be one owner at a time. And when the owner goes out of scope, the value will be dropped. What does that mean? It means when you allocate memory, Rust always knows who's responsible for that memory. So it knows basically which pointer, which variable is responsible. And that's why Rust can catch so many errors. So this is like an example right here. If we scroll down and we look at how strings work. Suppose you declare a string, let s1 equals hello. And then you do this statement right here, let s2 equals s1. So if you've worked with other languages, you know that this will behave like differently depending on the language you use. Sometimes it copies a string, sometimes it doesn't. sometimes what it does is this, right? You create a pointer S1 and it points to a string, hello. So this is very normal. This is like how C++ works. And then when you do what you call a copy, what you think is a copy, what you're actually doing is like creating a pointer that points to the same memory. So these are both like working with the same data, basically. Now, this is where Rust and C++ start getting different. In C++, this will remain just like this. What you're seeing is what's going to happen. But in Rust, eventually what happens is Rust does not want all these pointers pointing to the same location in memory. So it's kind of going to like make S2 the owner, as you can see. That's why S1 is grayed out. That original pointer, it's sort of like no longer in use. It's not valid. And Rust will do that at a certain point in the program. Rust will say, okay, you made a copy, but you can't have two variables responsible for the same data. And if this seems too deep and you're wondering like, oh, like this is like, I don't know why you would want this. Unfortunately, it is like a big topic. So you would have to kind of go through this and read it on your own. But long story short, it's how you avoid errors before you run the program. So let's get back to the presentation. There's plenty more here, especially concurrency. I suggest you read up on this. Concurrency is another section in this book, which is right here. I think it's chapter 17 or 14, chapter 14. It's somewhere here. Concurrency is all about making code that runs in like a weird order. So if you have, for example, a web server and you need to process requests and responses like on a web page, let's say you click a button and you need to get a response. While you're waiting for the response, you want other things to happen. So that's basically concurrency. It's having your program run in like these orders and taking advantage of all the time you have so that you're not waiting on one thing before you do another. So again, Rust is like built around this and it's really good at it. And this is why it's being used in industry, is mainly for this. So let's get back to the presentation. So now let's get into the command line application. So if you're familiar, a command line is it's just your terminal. Basically where you can run everything and it's purely text. What we're gonna build is a clone of grep. If you've taken Linux class, Unix, or you're just familiar with this, grep is a search tool. It's going to act as a filter. It's going to take an input of a string and a path, and it's going to tell you all lines containing that string in the path. So what do we mean? Let's say we have an example file right here. So cat just, this command right here, cat, it just displays the contents of this text file. So we have a text file with all these words. And what we want to do is build a tool that looks through these words, looks through every line and finds us the word and tells us what that line is. So if we say grep earth test.txt, it means look for earth in the text file. And so Rust is supposed to be like pretty good at very simple programs like this, where you're not really caring about like it looks pretty, it looks good. Just like I want it to run fast, even if it's a big program. That's where Rust comes in. So the first step is to install Rust. You don't have to follow along. You don't have to do this now if you want, but because it'll take a while and like you would have to do it on your computer. But the first thing is to install Rust. This is what it looks like. Give me a sec. So you just go here to install Rust and you use this tool called the Rust UP, Rust Up. And once you install it, you can of course check your, give me a sec. You can just check your version and then you should have it installed. And then you can check your compiler and everything's good to go. Now you're basically ready to use Rust at that point. And then here are the instructions. If we follow this link, give me a sec. Okay, so now we can set up the project. When you want to create a project in Rust, it's also very easy. It's really straightforward. So let's say we want to create a project, right? We just type cargo new and then the name of the project. In this case, we want to make a clone of grep. So we're going to call it Finder. You can call it Searcher, whatever you want. Once you do that and run it, then you just, you go into the project and now you have all these files that Rust generated. With just one line of code, you basically have like a template project. And if you go into source, SRC, right here, this is basically the main code, main.rs. This is your Rust file. Okay. And if you type in, now here's how you run the program. If you type cargo run, once you're inside that directory, that actually runs the program. So in this case, I already made this, I already wrote this code beforehand. And I'm trying to run it. I'm trying to run my grep clone, but it's giving me all these errors, and that makes sense because I haven't passed in anything. Like I have to basically do this. And then it gives me my output. So that's essentially how you run it. The next step, if you decide to make this project on your own, you want to add this to your resume, whatever, but you want to walk through all this, you should go through this documentation and go through it step by step. So it talks here about taking in the command line arguments. So I'll show you the actual code right now. First, you're going to import this crate or this library. It's called CLAP. So I think it stands for command line argument parser. Then you're going to create a struct. So this struct, all it's going to do is it's going to store the data. It's going to store your pattern or the word you're looking for, and it's going to store the path. So where are you looking? What are you looking for, and where are you looking for? You could do this without importing this library. You could do it kind of like what we might call the old-fashioned way, or like a very simple way. If you look at this code, this is like kind of what a beginner would do. They would just do this. They would use the environment arguments and then just access it by index. But Rust is saying you can actually use a library. Whenever you do any task, check if there's a library, because it's going to do the same thing but better. And the reason we say it's better is because if you use this library, it's going to give you like better error messages, for example. If you didn't, then you would get error messages that are maybe harder to understand. So if we look back at the rest of the code here, line 13, this is your main function. This is always going to run. So we declare variable arguments, and we actually parse what's being written on the command line. This is what the user types on the terminal. And then we store the content in a variable. We use the standard library. We use the file system module, and then we use a method read to string. And of course, it's stored, right? It uses arguments, which is this variable here. So if we say arguments.path, that's basically this. And then there's even like code here that handles the error message. You do .expect and could not read file. So now that we've actually parsed it, we've taken in the user input. Now it's time to actually do the search, basically. So now we can search for line and content. So basically for every line in the file, if the line contains the pattern we need, we just print it. And so we could kind of test this out. We already tested it, but we're gonna, let's say, run a bad arguments. So let's say we're looking for sandwich in test.text. So because I misspelled something, it's also going to tell me there's no file because I tried typing test.tx. Let's see what happens if I look for a word that doesn't exist. So it gives me 0 output because that word's not there. And of course, if we just type cargo run without any parameters, then it's telling you, hey, you're missing this. You're missing the pattern and you're missing the path. If you keep following the rest of this documentation, you will find that there is more you can add to this. You can include better errors that are a little more clear. You can add testing as well. Testing will obviously give your program like a higher quality. So this is the last thing I'll show you, which is kind of what tests look like. So if we take a look at this alternate code, we should see that this changes. Give me a sec. Okay. Interesting. Okay. So when you add tests, it creates a test folder. And there's a bunch of stuff here, not even going to bother going through it, but you can see here on line 19, this is like the main thing. This is your test. What actually gets tested? Again, you can look through your main code, your main.rs. On line 33, there's this line of code that's called like pound test. This is called an attribute. And this is what actually gets tested. So in this case, it creates like fake data. It creates this like almost fake text file. And then it runs our actual program to look for fake data in our fake file. And it just confirms that everything works. So assert is just a command that says, make sure that the output is correct. And yeah, that's basically how this program runs. Here are some resources that I used. I'll be sharing this so you can look through it. And yeah, that's the workshop, everybody. Thank you very much. I'll stick around here on the chat or whatever, take any questions, but thanks everybody for coming. If you got a split, go ahead. Thank you so much.
You're welcome. Thank you.
For sure, dude.
You can use emojis on Rust.
Yeah, you can use emojis.
That's so cool.